All right, this video is for Unit 3, Lesson 1. We are talking today about polynomials. So we will be adding, subtracting, multiplying polynomials today. So we talked about the definition of a polynomial. Polynomial is a mathematical expression that is the sum of several terms that contains different powers of the variables. So the powers for a polynomial are whole numbers. They have to be positive, they can't be negative, and they can't be fractions. They have to be whole numbers. So polynomials can be named by the number of terms in the polynomial. So for example, if our polynomial is a monomial, that just means that it has only one term, and an example might be 7x to the third power. So it has a variable x, the power is 3, it's not a negative power or a fraction power, so that would be a monomial. It's a polynomial that has only one term. A binomial, like a bicycle, has two wheels, a binomial has two terms. Something like 4x minus 5 is a binomial. It has those two terms that are being grouped by subtraction. A trinomial, like a tricycle, has three wheels. A trinomial has three terms. And you've seen lots of trinomials, things like x squared plus 2x plus 1 are trinomials. They could look like other things as well, but that is an example of a trinomial. Every term in a polynomial has a degree. It's the sum of the exponents of all the variables in that term. But for a polynomial itself, we would say that the degree of the polynomial is the highest degree of any one term. There's always one term in the polynomial that has the highest degree, and we call that the leading term. Standard form of a polynomial means that the terms are in order from the highest power to the lowest power. And the leading coefficient is the numerical coefficient of the term with the highest power in the polynomial. That's a lot of words. So let's look at some examples. For this polynomial f of x, it's a binomial. It has two terms. And it has the term right here has a power of 3, and the second term has a power of 0. It has 0 powers of x there. So we would say that the degree is the highest power of any one term, so this polynomial itself is a degree 3 polynomial. 5x is to the third power is its leading term, so its leading coefficient is the number 5. The degree of the polynomial and the leading coefficient of the polynomial always come from the same term, we call it the leading term. G of x is a little bit different because it right now is not written in standard form. Standard form means that those terms have to be in order from the highest power to the lowest power. So if we rewrote g of x in standard form, that power 2 term would come first, and the constant term, the 1, would come second. So it'd be negative 6x squared plus 1. So if you think about those two terms, the degree and the leading coefficient come from the leading term. So the degree would be 2 and the leading coefficient would be negative 6. H of x is a trinomial. It has three terms, and it is already written in standard form, highest power to lowest power. So our leading term is this one. That will give us our degree and our leading coefficient. So this is also a degree 2 polynomial, and it has a leading coefficient of 7. J of x is also written in standard form already. It has three terms. Now, j of x is multivariable. So, yeah, it's actually, anyway, it's multivariable, so it has three terms, and to get the degree of each term, we would have to combine. So this term, it has 4 powers of x and 3 powers of y. So that term itself is a degree 7 term. This next term, it has x to the power 1 and y to the power 1, so it is degree 2. And the last term, the negative 5, is degree 0. So the degree of the polynomial itself will be based on this leading term. Its degree is 7, and its leading coefficient is 8. Now, please note that while I did add together the 4 and the 3 to get 7, I did that because this is all one term. You would not want to add together the powers here, like to degree 3, because these are two separate terms. You only add the powers if it is the same term, and this is altogether one term. The power of that term is 7. Okay, so I just want to talk about some common polynomial functions in terms of their types of functions. You've already seen some of these. If a polynomial is degree 0, so I'm talking about this first row, if it's degree 0, it will literally look like f of x is a number, like 7, or it could be 2, could be any number. Standard form is just f of x equals a number. That's a degree 0 polynomial, and we call those constants. It doesn't matter what value x takes on, the y value always stays the same, whatever that number is. The next type, degree 1 polynomials, you have studied a lot in the past. So they would look like a number times x plus another number. You've probably seen it written a lot like this, mx plus b. These are linear polynomials, and usually you don't see that 1 power written on the x, but it is a degree 1 polynomial. So something like a function is equal to 1/2 x plus 3 would be a linear polynomial. It is absolutely 100% fine to have a coefficient that's 1/2. You just can't have a power that's a 1/2. The next type, degree 2 polynomials, you have also studied a lot before in the past. We call those quadratics. So it would be a number times x squared plus a number times x plus a number when it's in standard form. And a lot of times the letters that we use for that are ax squared plus bx plus c. So this form I'm using uses all a's, but those just stand for numbers. So a quadratic might be x squared minus 5. That one only has 2 terms. That just means that this middle term is a 0x, and that's totally fine. Okay, the next type, I bet you can guess what it's called. It's a degree 3 polynomial, and we call it a cubic polynomial. Something like x to the third minus x plus 2 would be a cubic polynomial. Again, it's okay for one of the terms to be 0. This one has 0x squared. Just fits better if I do a 0 for one of them. Last type, degree 4, is quartic. Now we do kind of expect you to know these words to describe them. It's more about you knowing what I'm talking about, though, if I say this is a cubic equation or this is a quartic equation, that you know what I'm telling you is the power of the polynomial. So there are names for some of the higher powers than that. Degree 5 is quintic. Degree 6 has a name. It's just not important to go any higher than that, though, for what we're doing. So if we go any higher, like this one right here is 7 times 8 to the power x plus 2, we would just say it's a degree 8 polynomial, and that is good enough. So if it said create a cubic binomial with a leading coefficient of 7 in standard form, the cubic is telling you that it's going to have the highest power 3. A binomial is telling you that there are going to be 2 terms. 1, 2. I'm going to put a plus in between. The leading coefficient of 7 tells you that this is going to be the first term if we're just using x for our variable. It needs to be in standard form. That means it needs to be in order. So there's nothing to really tell you what specifically that second term should be. So you could pick any old term there. The only thing you couldn't do is you couldn't pick a higher power because now it's a degree 5 polynomial that's not in standard form. So whatever goes here, it has to be a lower power than the 3. So this would work, and numerous other things would work as well. Create a degree 5. That's telling you that the power of the leading term is 5. Trinomial means we're going to have 1, 2, 3 terms. Leading coefficient of -1 means that's a negative x to the 5th, and in standard form. So maybe we finish it off with 2x to the 3rd minus 4. Again, you could pick pretty much anything for those last 2 terms as long as it wasn't higher than x to the 5th. Now, if you were feeling really crazy, you could even have something like this, where your degree 5 comes from multiple variables. Okay. So when we're working with polynomials, if we have a polynomial with lots and lots of terms, we can combine terms that are alike. So if 2 terms have the same variables with the same powers, they can be combined. So this first expression has 5 terms, but right here I have 2x, and right here I have 6x. So that could be combined. I have 2x's here and 6x's here. I could combine that to be 8x. Constants can also be combined. This is a -6, and I'm adding 9 to it, so that could simplify to a 3. There's not a like term to combine with the 5x squared, so it would just stay. So our final answer would be, our simplified answer would be 5x squared plus 8x plus 3. So which of these terms are alike? They have to have the same variables with the same powers. So the 17x to the 3rd y squared can combine with other x to the 3rd y squareds. So these are the 2 that you could combine to start. So that would be 12x to the 3rd y squared. There is not another x to the 3rd term, so that would just stay as is, nothing to combine it with. And we also have over here a y squared term, so that one will also stay the same. We can combine our constants. I have an 8 and I have another 4, so that would be plus 12. So this would be my final answer, 12 x to the 3rd y squared plus 14x to the 3rd plus 3y squared plus 12. One last one to try. T to the 4th here. Here's another t to the 4th term, and here is a third t to the 4th term. Look for all of the ones that are alike. So this is 7 of those plus 9 more. Subtract 1 of those. So 7 plus 9 minus 1 is 15 t to the 4th. I have just this term that's t squared. I don't see any others, so that would stay as is. We've got -8t and +2t for -6t. And we have a 7 minus a 6, so +1. So combining terms is just a way of simplifying the polynomial because there's no reason that they need to stay separate if they have the same variable. We can combine those and get a little bit smaller polynomial, a little bit easier to work with. Okay, so adding two polynomials together is really just a matter of combining like terms. So the parentheses are just saying, hey, here's one polynomial and we're going to add it to this other one. Those parentheses don't mean multiplication. The operation is right here. This operation says that we are adding. So when you're adding, it's really a matter of combining like terms. We have 3x squared and another 1x squared for a total of 4x squared when we add. Oh, I don't know. Sorry, I don't know why I wrote the fourth power. I said squared, but I wrote fourth. We have negative 5x over here, and we're adding 2x, so that would be negative 3x. And then finally, we have 7 plus negative 1. And so that would be 6. So there is our addition. I'm going to skip this one for the video. We kind of did a similar one with the x's and y's before when we simplified. Okay, subtraction, while it is, more or less the same as adding, it's always much more difficult for people because you have to be so careful that you are subtracting the entire polynomial. So we're going to do, this is in function notation. It's saying here's a polynomial f, another polynomial g over here. This notation just means take polynomial f. So that would be 5x squared plus 3x minus 6. And subtract polynomial g, 3x squared minus x plus 5. This thing right here is just of x, the same as like f of x. This is just f minus g of x. It's just kind of naming the variable and telling you what the variable is going to be. Okay, so f minus g, function f minus function g. It would be the same as adding, but you have to remember that the subtraction applies to every single term here. It applies to this term, it applies to this term, and it applies to this term. So sometimes people think of that as distributing the negative. The minus applies to the 3x squared. It applies to the negative x, and it applies to the 5. We have to subtract each of those terms. So when we do that, and again, some people kind of think of it as distributing the negative. If that helps you, that's fine to think of it that way. Once you have made sure that you are applying that operation of subtraction to every single term, then you can combine your like terms. Now this one right here, that's a minus a negative x, subtracting a negative is the same as adding. So that's essentially plus x. So I have a 5x squared and a negative 3x squared. That gives me 2x squared. I have a 3x and a plus 1x. So that's a 4x. And we have minus 6 and minus 5 for negative 11. So there is our simplified answer. So in class I had you practice a couple, or I had the students practice a couple. I'm going to do part B and part C really quick. So make sure when you're doing subtraction that you think very carefully about the order. This says you're starting with function g, so that's 14x plus 20, and we're subtracting function f. So we're subtracting 2x to the third plus 7x minus 5. That subtraction applies to every term. It applies to this one, it applies to this one, and it applies to this one. And then this, so I'm going to rewrite that. 14x plus 20 minus 2x to the third minus 7x, and this becomes a plus 5. So when we combine our like terms, I'm going to lead with that highest power. The 14x and the negative 7x combine to be a 7x. And the negative 20, or sorry, that's a positive 20 and a positive 5 is 25. So this notation in part C, g minus f of 5, well, we just figured out what g minus f of x was, and it's this. This is that. So if it says g minus f of 5, that's literally just telling you to plug in the number 5 or substitute the number 5 in for x. And so when we calculate that in our calculator, negative 2 times 5 to the third power plus 7 times 5 plus 25, punch, punch, punch in your calculator, you get that g minus f of 5 is equal to negative 190. What do you call a parrot that won't eat? A polynomial. Okay, sorry. um, subtract 3 from 5. What does that mean? Subtract 3 from 5. It means that you started with 5 and you subtracted 3 from it. So words, sometimes subtraction wording can be sort of flipped from what it really means. When I say subtract 3 from 5, I mean start with 5 and take 3 away from it. So with polynomials, if I want to subtract 2a to the third plus b minus 3 from 8a to the third plus b plus 4, the 8a to the third plus b plus 4 is what I'm starting with. And I'm subtracting the 2a to the third plus b minus 3. Remember, when you're subtracting, that operation of subtraction applies to the first term, it applies to the second term, and it also applies to the third term. When we subtract a negative 3, we are adding a 3. Okay, so we have this now. We made sure our subtraction applied to every term. So now we can combine our like terms. We would have 6a to the third. We have a b and we have a minus b. B minus b is 0, so we don't need that to be represented in our polynomial. You, of course, can write 0 if you want, or even 0b, but it's not necessary to have it there. And then the last term is a 4 plus a 3, so that would be a 7. So that's what our subtraction would result in. I'm going to skip over this one. It will give you, you would work it out the same way. It just has a couple variables. Last topic of the day, multiplying polynomials. So when you're multiplying things that have addition, like so, you do have to make sure that you are distributing. The a multiplies the b as well as multiplies by the c. So it's a times b plus a times c. So this first example, if we times negative 5x by the polynomial 3x plus 1, that negative 5x multiplies here. That gives me negative 15x to the third power. This is an x times an x squared, x, which would be x to the third. And then we multiply by 1. So this would be our result. Over here, if we multiply that x to the third by the x squared, x to the third times x squared is x to the fifth. X to the third times x is x to the fourth. X to the third times negative 4 is negative 4x to the third. So that is distributed. And distributing is all fun and games until both of your polynomials have two terms. In this case, we're going to multiply a couple of binomials together. So I have x plus 2 times x plus 7. Just like before, if this had just been a 2, let's see, like if I Um, if it was just this, we would distribute that too. If it was just, oops, sorry. If it was just this, we would distribute the x. Well, when it's both, that means we just have to distribute both parts. So I have to distribute the x, and again, our operation is multiplication. X times x is x squared. X times 7 is 7x. But I also need to distribute the 2. 2 times x is 2x. 2 times 7 is 14. So oftentimes you end up with a couple of like terms when you do this. So in this case, our final answer would be x squared plus 9x plus 14. And I think I'm going to skip that practice one. There's some notes posted that will show you the answer to that if you want to check your work. We can even multiply a binomial by a trinomial. Again, just like before, if we just had, let me black that out, sorry. If we just had the 4, we would distribute it. If we just had an x, we would distribute it. When we have both parts right there, I just distribute both of them. So I'm going to distribute the x first. X times x squared is x to the third. X times 2x is 2x squared. And x times negative 5 is negative 5x. So that is completely distributing that x. Now we need to go back and distribute the 4. The 4 will multiply by the x squared. That's 4x squared. Now I like to keep it lined up like this. I put it right below its like term, so I saw that 2x squared right above it, and I said, okay, if I'm going to put a 4x squared somewhere, I'm going to line it up below. That's just a preference. You could list it over here if you wanted. I like to stack it because then it's easier to combine for me. So the next one is 4 times 2x, so that's going to be an 8x. Again, I lined it up just below its like term. And the last bit of multiplication is 4 times negative 5, and that's a negative 20. So we multiplied every combination of those terms together, and now to write our final answer, we just need to combine the like terms. That's why I like to group it like this, because now I can just add up my like terms. That'll be a 6x squared. This is going to be a positive 3x, and then a minus 20. Okay, we made it to the last problem. What if you wanted to multiply 3 things together? Like x plus 3 times x minus 2 times x plus 5. So think about what you would do if you had 3 numbers that you needed to multiply together. And you didn't have a calculator. 5 times 2 times 17. Well, most people can look at this and sort of see an answer of 170. And it's okay if you're not there, but let me show you why some people might get to 170 pretty quickly. They think about this, 5 times 2, and that's something that you probably know is 10. So by timesing these two together and getting this product 10, I can take that result and multiply it by the third thing to get my answer, 170. We're going to use the same idea with our polynomials. If I have 3 polynomials that I need to multiply together, if we multiply them together, 2 of them, we can multiply that product by the third one. So I'm going to pick these 2. I just like to do it that way personally. You could go in any order. That's just my preference. So I'm still going to have to multiply by x plus 3 in a second, but first I'm going to multiply x minus 2 times x plus 5. Well, if I distribute that, and I combine my like terms, I get x squared plus 3x minus 10. So now I need to take that x squared plus 3x plus 10 and multiply it by the x plus 3. Whoops. So if we distribute that, I'll distribute the x first. That's an x to the third power. It's an x times an x squared. And I'm going to multiply that x by the 3x, get 3x squared. And we can multiply the x by the negative 10 to get negative 10x. So I distributed that first term, x plus 3. Now I'm going to distribute the 3. I've got another 3x squared. Now I'm just multiplying the 3 by the 3x to get 9x. And finally multiplying the negative 10 by 3 to get negative 30. So if I combine my like terms, I have x to the third. These two combine to be 6x squared. These two terms combine to be a negative x, or negative 1x if you like to write the coefficient. And that last term is negative 30. All right, so that was adding, subtracting, and multiplying polynomials. I hope you enjoyed it.